Today's lesson is solving equations involving fractions. So the first example I have here is 2 being equal to a third of x plus 5. Now we can follow our rules for solving equations just like we've done before. I could undo the adding 5 by subtracting 5 from the right side, but if I subtract 5 from the right, I have to do the same from the left. So 2 take away 5 on the left should equal -3, and that will equal 1/3 x. And the plus 5 and the minus 5, they undo each other, and that was the whole purpose of that. All right, now if I have a 1/3 x, that's the same thing. Our x really has a 1 on the bottom of it, and the rule when we're multiplying fractions together is that we multiply our numerators together, so 1 times x is x, and then 3 times 1 on the bottom would be a 3. Okay, so now to get the x by itself, it's being divided by 3, so to undo that, we're going to times both sides by 3. So I want to take that -3 and multiply it by 3. So -3 times 3 is -9, and that will be equal to, and the divide by 3 and multiply 3 undo each other, leaving us with just x. So x equals -9 is our solution. So if we sub that back into the original equation right here, if I do a third of -9, that would be -3, and then -3 plus 5 gives me the 2 that was on the left side. So we know we've done the equation correctly. Now I want to show you another trick to these. This works fine and dandy. There's no problem with solving it this way. When we get into some of our more complicated questions, there's actually an easier way, or a way to eliminate the need for working with these fractions. So I'll show you that off to the side here. I'm going to say or. Okay, so this is a second solution to this particular question. I'm going to start with my equation. 2 equals a third of x plus 5. Now, it is a fraction. There is a fraction in this question. The fraction has a denominator of 3, and that's the only denominator there is. So our common denominator, CD, common denominator, is equal to 3. Now we know with equations, as long as we do the same thing to both sides of the equal sign, to both sides of the equation will still be true. So this 1/3 that we have right here, that really is the same thing as a divide by 3. And you'll notice that's really what became over here in this solution. The 1/3 times the x became x over 3. And to undo that, we multiplied both sides of the equation by 3. So that's what we're going to do here. We're going to multiply both sides of the equation by 3 as a starting point. We're going to multiply both sides of the equation, multiply both sides of the equation by the common denominator. Sorry for all the clicking here. I'm just going to put on pause and write that in and then push play again. Okay, so we're going to multiply both sides of the equation by 3, which really is the common denominator. So that'll become important with other questions that we do. So I'm going to take that 2 and I'm going to multiply it by the 3. So I'm taking the thing on the left side, I'm multiplying it by 3. And I'm going to take the right side of the equation, which is the 1/3 x plus 5, and we're going to multiply it by 3. Now in multiplying it by 3, I'm just going to undo that arrow there. In multiplying by 3, we've got a couple of rules that we have to keep in mind, but we'll start with the easy part. We've got 3 times 2, which is just a 6. So on the left side of the equal sign, we have a 6. Now we know from our distributive law that the 3 is going to hop through this bracket, and when it does, it multiplies. So if I have 3 times 1/3 of x, so starting with this first part, 3 times 1/3, or 1/3 of 3 is just 1. We're going to get a 1x out of that first multiplication. And then we have 3 times the positive 5, which would be a plus 15. Now this equation is much easier to solve in terms of not having to worry about any fractions. We can subtract 15 from both sides. So on the left side I have 6, and I'm taking 15 away, and that gives me -9. And that's going to equal 1x. Or just plain old x, 1x or x, is equal to -9. So same answer, just a different approach to it. All right, so part B, we've got a couple options again. We could expand first because we talked about needing to expand through the brackets first. And then, so if I did that, I would get 2/5 times the x, and then minus, now this would really be a 3/1, multiply the numerators together, so 2 times the 3 would be a 6, and then 5 times the 1 on the bottom would be 5, and that's going to equal 11. And then I could add 6/5 to both sides, so plus 6/5. And that leaves me with a 2/5 x, or 2x/5 when I multiply those two things together. That's really like a 2/5 times an x/1. So 2x/5. This piece, the minus 6/5 and the plus 6/5, is gone. And then we've got to put these together. So 11 is really the same as 55/5, and that's just getting a common denominator to turn that 11 into a fraction that I can put together with my 6/5. So if I have 55/5 plus 6 more fifths, all together I'd get 61/5 being equal to 2/5 of x, or 2x divided by 5. And then at this point, that's a 2 by the way, at this point I need to get x by itself. It's being divided by 5, so I can multiply both sides by 5. So there's that common denominator that's multiplying both sides in the end. So that 5 and 5, they eliminate each other, they undo each other. It leaves you with 2 x's being equal to, and then we need to, or we can eliminate these 5's, equals 61. Then we can divide both sides by 2, and we get x equals 61/2, or 30.5. Okay, now I'm going to show you alternate solution here. I'm going to put or in here and hope I can squeeze all this in. All right, my other option is to follow my rule that I had over here, which is to multiply both sides of the equation by the common denominator. And since this equation only has one denominator, and that denominator is a 5, the common denominator is 5. So even though the 11 doesn't have a denominator, it still has to be treated fairly. We're going to still multiply both of these sides of the equation by 5. Okay, now in doing so, what this says is I have 5 times 2/5 times the x minus 3. So I'm going to actually do the multiplication right here first. I'm going to go 5 times the 2/5, and that's going to leave me with just a 2 times the x minus 3. And on the right side of the equal sign, we have 11 times 5, which is 55. Now this question looks like yesterday's questions, where we're just going to apply distributive property. And then that gives us a 2x minus 6 equals 55. I'm going to add 6 to both sides. And then from there we're left with 2 x's being equal to 61. And then divide both sides by 2. That's supposed to be a 2 there. And we get x equals 61/2, which is the same solution as we got with the other method. But I think the second method's a little bit easier because I don't have so much work with fractions. All right, so I'm going to use that second method with the equation in part C. So if I look at my equation here, I'm looking for my common denominator. I only have one denominator. My denominator is a 4, so my common denominator equals 4. I'm going to multiply each side of that equal sign by a 4. So I'm going to have 4 multiplying this fraction of, let me write all that down, and that's going to equal 4 times the 8. I'm going to times this side by 4 as well. So both sides get multiplied by 4. Now, in this question, like I did with the previous question, so over here I took my 5 and my 5, and I did the division piece to that. Let's see if I can get that there. Whoops, I went a little too far. So I'm going to do the same thing with this particular question. I'm going to do 4 the multiplying by 4 is going to cancel out with the dividing by 4. So what I'm going to be left with is a 3 bracket y minus 5 equaling, and then 4 times 8 is 32. And then we can expand through, bloop, bloop, get 3y minus 15, is equal to 32. Then we can add 15 to both sides. Plus 15, plus 15, plus 15 again. And that leaves me with 3y's being equal to 47. And then divide both sides by 3. And y is equal to 47 divided by 3. So hopefully that makes sense. I have a couple more questions on part D and part E, but I'm going to do those on another video so I can upload this.